the airports, driver license applications, and then forensic applications identifying victims. So here is the problem of multiple enrollment. As I mentioned, the state of Florida has about 51 million faces in its database, and what they would like to make sure is to clean the database and purge any duplicates. That is, same person who has been issued multiple driver licenses. In order to do that, what you have to do is you have to match every face with every other face. So that's a very difficult problem, you know, matching 51 million faces against 51 million faces. I mean, that's computationally very hard problem. And right now, the face recognition technology is not so advanced that it can find all the duplicates. But in a prototype in which I was involved with this company, you know, they found about 5,000 duplicates by matching 700,000 face images against a database of 51 million face images. So that means it shows us that there are a large number of duplicates, and the only way to find the duplicates is to match faces, because if you do a name-based search, if somebody used an alias, you will not find the duplicate. So we know now that what is the face recognition problem, why is it important, but why is it so difficult? Well, first thing you have to do is when you recognize a face, is first you have to locate the face. And that's why surveillance problems are so difficult. If you have a camera at the airport and it is taking images, then if you want to recognize a person in it, first you have to locate the face. And this face location problem is very difficult. It's a two-class problem. Is something a face or something is not a face? But it turns out that that's a very difficult problem. Then there's a problem of identifying similar faces. So there are people whose faces look rather similar, especially if you happen to be, you know, siblings or father and son sometimes have similarities. So the system should be able to differentiate between them. Then accommodate intra-class variability. That is, the image of the same face taken at different times of the day or under different lighting conditions, under different backgrounds, during different time periods appear quite different. And so the system has to accommodate for the pose of the head. Is it frontal pose, what's the side pose, illumination conditions, expression. And that's why right now these systems work only for neutral expression. So when you go get your passport picture or driver license, you're not smiling, crying, and so on. You know, you're supposed to have a neutral expression. And if you don't have a neutral expression, the automatic recognition systems don't work very well. And finally, the aging effects. So what I'm going to do is to just illustrate some of these problems. Here's the problem of face detection. All right. The way the face detectors usually works is that you take some examples, training examples of faces, and some training examples of non-faces, and you design a learning algorithm which will separate faces from the non-faces. So in this particular example, Professor Pavlidis, who was a professor at SUNY Stony Brook, now retired, he created a composite in which he put his face next to the undesirable person's face. You know who this person is, right? And it turns out that it didn't find the desired face, but found his face. And the reason for that is that the training is based on facial appearance, and the training set probably didn't include such heavily occluded face where there's hardly any facial features which are very evident. So this is one of the major problems. Before you first recognize a face, you have to detect it, and detection does not always work. Here is an example of intra-class variability. If you start introducing pose, lighting, and expression changes, the current best of the state-of-the-art systems do not work very well. Occlusion. Now, partial occlusion works. So one of the best face recognition systems is by Cognitech. So if you cover with a scarf part of the face, the system still can recognize you. But if you wear dark glasses, the system doesn't work. And the reason for that is one of the main steps in doing face recognition is to find the center of the two eyes, because you do the alignment of the faces based on the center of the two eyes. So if you have dark glasses, then this alignment step gets failed, and so the recognition system doesn't work. And finally, the aging. At the bottom row, these 6 facial images are of the same person taken at different times. And again, the current face recognition systems cannot work. On the right column, I have shown you the sketch which the police artist made. And this is real database provided by the Michigan Forensic Department. The sketch and the corresponding mug shot, that is, that person existed in the police database. And this was not found by automatic matching. This was found by posting the sketch. And then people came forward and said, yeah, this is the guy who committed this crime. So this is an example of inter-class similarity, different persons who are similar in facial appearance. So identical twins, they look alike, but they're different persons. And there have been cases where one identical twin committed the crime, okay, but the other one was arrested. I told you about siblings, father and son having similar appearance. These things are difficult to detect automatically. The next problem, the biggest problem in face recognition or any pattern recognition problem or object recognition problem is representation and matching. How do you describe the object, in this case face, and how do you store it, and then how do you match it? And the most common approach in face recognition community is appearance-based. That is, you basically look at an image of the face, let's say it's 300 by 300 image, and you look at the gray value. Most systems don't use color information, they use simply gray values. And you try to study the distribution of these gray values in the form of covariance matrix, and then compute eigenvalues and eigenvectors, and describe a face in terms of a low-dimensional representation in the eigenvector space. And so one of the first methods proposed was PCA in late 1980s, and that sort of started most of the activity in automatic face recognition. And then it was generalized to LDA, linear discriminant analysis. Some other approaches have a hybrid of feature-based and appearance-based method, and this is where LFA comes in, local feature analysis. It's a combination of local features, for example, some features in the neighborhood of the eyes and the mouth corners, as well as the appearance-based methods. What we would like to have is a method which is pose-invariant, that is, have some kind of a three-dimensional representation of the face, store that, so that no matter in what pose the face appears, we'll be able to recognize it. So this is the challenge associated with the video surveillance. So let's say we have this is a scene at the airport, and in order to recognize all the people in this image, and I'm sure you can recognize some of the individuals in this image, first you have to do the segmentation. And this is the segmentation which I have shown in this image is actually done by the Viola and Jones face detector algorithm. So it does a reasonable job in finding the individual faces. And after it finds one individual face, now you have to match it against a gallery database. Okay? Again, some of the older people in the audience can tell who this person is. Anybody knows who this person is? You'll be, yes. But then, which image is stored in the database? I mean, I've shown you several images of the Yul Brynner starting from 1959 to 1973. And this means that you have to constantly update the template which is stored in the database in order to make sure that the algorithm works correctly. And that's why after 9/11, several face recognition systems were installed at some of the major airports, particularly Boston's local airport, where most of the hijackers boarded the flight, and the system didn't work at all. And even the current best of the surveillance or face recognition systems would not work in such difficult environments. The other problem with face recognition system is that people can camouflage the face. I mean, this is the same person who has disguised himself by just using makeup and other kinds of things.